Electronics 14. Here we go. So, what we're going to talk about today is I've been looking up a bit about what we've been talking about, but what are we looking at about pumps as well? Pumps are pretty interesting actually because they put water to a higher level. So I'm going to talk a bit about that, and I've actually done a little bit of research here. So I might not. I'm not sure if I'll write it down, but I'll certainly mention it in things I'm going to say here. All right. So where we ended it before. We ended it before. We were talking about electrons. We were talking about the wax in the wall. Remember, of course, the wax had the, once they were rubbed together, the wax had the surplus negative charge, and it wanted to try to, if we put a wire in the middle, it wanted to kind of, sort of just send those electrons over to the wall, which had a deficiency, a positive charge. So and we said, didn't we? We said we don't need these. The electric charge formed between these two materials seems to share, distort. You know, by the way, this is an interesting thing. This and this are completely different. I didn't even realise that. I was thinking, wait a minute, wasn't that upside down there? They are completely different. It's funny, isn't it? I've been looking at loads of stuff recently. I've been looking at Newton's first law, all sorts of stuff, really. Just some funny stuff. Right. Seem to share. So that's what I just said this, and now we're going to get into the pump stuff. And the pump stuff is pretty interesting. I was looking at that, and I was remembering some of the stuff that I learned before, because I learned quite a lot of. To be honest, I've learned a lot of stuff over a long period of time. So. And one of the things is that even though these, from what I gather, I was looking at this sort of like, this hydroelectric sort of power generation sort of thing. And one of the funniest things is that even though they seem to have a sort of a net kind of loss on the sort of amount of energy they get back, it's like because sometimes electricity can have a negative cost. Sometimes it still can make money off that. It's pretty strange, really, when you think about it. But, well, I don't know. I used to find that quite strange, but nowadays I don't. It doesn't make any. Not a lot of things make that much sense anyway. So that's why you have to do all kinds of nerdy stuff. Unlike the energy stored in a high reservoir of water. Has been pumped from a lower level pond. And when I saw this, I was like, wait a minute. And I remember, I've thought about this issue so many times. Like, you always see a waterfall, don't you? But then you think, wait a minute, isn't that waterfall just going to end when it all reaches the bottom? And the reason it doesn't end is because of capillary action. Like, the waterfall's next to a tree or something, the leaves can actually, I believe it's 30 feet from what I looked up, will actually get the water upwards, and it's the same why if you have it's to do with the surface area. So I remember in nanotechnology as well, surface area plays a ridiculous role as well. So luckily, because obviously a lot of people I suppose nowadays looking up stuff on nanotechnology, and I kind of knew all about this surface area business. Well, probably not, but I know I kind of All right, so what is going on here? Well. This is sort of like, I don't know, it's sort of, this is a pond, and then we're going to pump up the water through this. I was thinking, because apparently you can have like a turbine, but then the reverse of a turbine is a generator. So doesn't make much sense. But like I say, this is very, very early on, so a lot of stuff I'm going to be saying, I'm probably not really going to, at the end of the day, I don't really know quite what's going on at the moment, but this is electronics, and this is just a little analogy section anyway. So here's the reservoir. So what we do know is that there's a pump here, and there's water flow. So there's energy stored. So yeah, it kind of makes sense, doesn't it? That you pump and there's going to be energy stored, and I think the energy is actually in the water. It's like pressurized water, isn't it? Because that's the only reason it's going up. Because it's getting pumped. It's been pressurized upwards. So I guess that's what's going on, and then it's storing the energy. And I guess maybe from there that's where you turn it into electricity. I guess it's something like that. I'm not entirely certain though, but it seems like that would kind of make sense. Because what you can do is you store, because even though you have to actually power the pump itself, it'll be able to do that sort of conversion process somehow. But I don't want to think about that. Yeah, I mean, I sort of, luckily I already do kind of think about these issues sometimes anyway. So that's what happens there. So this is your basic sort of setup for the pump into the generator. And the reason, of course, I'm talking about this is because there is a direct relation to electronics. I'm not just randomly coming out with this stuff as something which is not related, because it is. Did I say this is 14? This is electronics 14. If I didn't put that at the top, then it is electronics 14. Let me just check that. Yeah, I did get it correct. All right. So if there's a gravity on the water in the reservoir, all right. Like I said, I'm not being particularly neat at the moment. At the end of the day, it's a mixed bag. Sometimes I will be neat, sometimes I won't be. I like to think that, I mean, I can read what I'm writing here. So I like to think that it is readable. And luckily, I spell words correctly and stuff like that. So that's hopefully make things a bit more readable. So the influence of gravity on the water in the reservoir creates a force that attempts to move the water down to the lower level again. I have to admit that capillary reaction stuff is pretty cool though. I like that. I like the thought of that. And apparently, if you put a plastic bag around a load of tree leaves, water will accrue in there. Attempts to move the water down to the low level. It's pretty obvious. You're pumping it back. The gravity is trying to push it back down. I mean, that's yeah. That's the thing. I don't like to think of anything as common sense, because a good thing to do is just always ignore common sense, because common sense doesn't actually make any sense. All right. So if a suitable pipe is run from the reservoir back, okay. So yeah. So we're going to move on here, back to the pond. The pond there. Yeah, I mean, I suppose it probably would. I guess if I'd learned about, I just haven't, The problem is my engineering maths is not really very good, if I'm being honest. I'm not good at differential equations and all this stuff. I never got good at that. I was always into other types of maths, really. So it's like, yeah, I'm going to have to improve that. I need to improve. I mean, it's funny, I know derivatives, but I'm not good at the integrals, but integrals are way before derivatives. I don't know why that is. Water will flow under the influence of gravity. Down from the reservoir and through the pipe. Yeah. So I looked up a lot of things really, and it's pretty interesting. I do want to look more into hydroelectric generators and turbines and stuff. And there's actually something. So basically, like I say, I'm not quite sure. Yeah, I believe this is actually the correct way to draw a reservoir. I think all these sort of things, probably this is another sort of like thing in geography as well. Yeah, I was actually quite interested in that, like silt and stuff like that. I'm not quite sure what these are supposed to be, whether they're supposed to be like fangs or little teeth or something. I'm not sure what's going on with that. But yeah. So yeah, so as you can imagine, did I draw? I probably, well, yeah. So the water flow is going up here. Yeah, like I say, it's not not tremendous diagrams here, but yeah, I'm always looking for a solution for this thing. But I just like fucking doing things by hand so much that I don't really like to. I don't know what it is. I just like to, it's why I got a graphics tablet, because I like to actually, this is obviously a tube here. I like to draw stuff. I don't really give a shit how good I am at drawing. It's not like, sometimes it don't turn out too bad, to be honest. Sometimes I looked at it and I thought, yeah, that turned out all right, actually. So, but yeah, so that's basically what happens. Obviously, the energy is released. So it's stored when it goes up. So yeah, I mean, I guess maybe you could think of it as accruing over time. I mean, that must be the way. Everything's always over time, isn't it? So it's probably like as it goes up, it gets more energy. As it goes down, it releases more. You know, I'm going to go with that. That sounds to make sense. It seems to make sense with what I can think about. Always the fact that it's always to do with time. These differential things, and everything, all the computer stuff, the whole lot of it, really. So I'll just go with that. Log n time. Probably logarithm. Yeah, in fact, it is logarithms. I know logarithms are in this. I've been looking at quite a lot of this. What we're going to talk about anyway. But like I say, I'm not really going to get ahead of myself because I like to. I mean, I can't anyway. I've got to do it. So, at the end of the day, that's just how it's got to be. So, it takes energy to pump that water from the low-level pond to the high-level reservoir. And yeah, and this is I actually quite like doing this. I always like to. It's something quite cool about being very precise and saying the same thing again and again. That's really the way you've got to look at it. And the movement of water through the piping. So this is like the process chain. This is I like that through the piping. Back down to its original level. Of course, afterwards it will become all about numbers and stuff. But I like the process chain. So at least if we're going to have to deal with numbers constantly, it will make sense within the process chain. So there's no real amount of time that you could spend on the process time that is long enough, really. So yeah, so if we take the water from the high level pump to the high level reservoir and moving the water through the piping back down to its original level constitutes a releasing of energy stored from previous pumping. All right. Alright, so if the water is pumped to an even higher level, it's going to take even more energy. So this is the point where I was actually alluding to a little bit before. It will take even more energy to do so. But this, I believe, is actually what is desirable. So you want a bigger distance. Yeah, and the reason for that, of course, is thus more energy will be stored. More energy will be stored. And then, of course, with electricity as a negative cost, you can end up. I think that's how it works and how these systems actually work. Even though they've got a net loss in terms of, yeah, well, that's what everything's got, net loss. But anyway, but I don't think it's that great. I think like some of them are probably much higher. It's like 70-85% or something like that. I think that's pretty crap. That's more energy will be stored. But yeah, like I say, I don't know. I do aim to get better on that sort of information about how these systems work and more energy. But I think to be honest, electronics may actually help me to do that. I don't want to think about I don't know. It's kind of weird doing this because this is like a real world system, whereas electronics you see is slightly different. But I don't know. More energy will released. More energy released if the water is allowed to flow through a pipe back down again. But yeah, it's interesting though. But I do wonder, like, I mean, yeah, it's not really relevant. But I just, just wax lyrical for a moment. I do wonder if, like, is this stuff like, like stuff with like resistors and capacitors, how that is actually, it must have come about through like these real world concepts like this, like the pump and stuff, and generators and turbines and all this sort of stuff. And I guess that's why they're so kind of interesting. So yeah. So now what I'm going to do is I'm going to just draw the complete system. I'm going to draw two complete systems. So we got the pump. Now I'll try and draw this one a little better. Energy stored, and we're going to go do that to indicate that we're going up. And we're going to go into the reservoir here. So here is the reservoir. And we'll draw these things. I wonder what, I'm really not sure what those things are. I think they must be something relevant there. And then that's going to go like that. And this is going to be energy released. So the reason I'm drawing it is because I want to compare to this system over here. So it's going to be basically the same sort of thing here, but we're going to draw the pond a bit lower, and this will help to sort of see that. So we do the pump here, and we're going to go to the same height. So I want it to reflect what's going on with this one. That's why I wrote compare there. Here's our reservoir. Try to make it relatively similar sort of size. I'm certainly not trying to differentiate that in any way. And then this is more energy released. And then this is more energy stored. So yeah, so that's the advantage then. You can store more energy. So it's like a more bigger capacity. I guess that's to do with capacitance. Capacitance is kind of the interesting thing about electronics at the moment for me. I'm not sure. I'm not really sure where resistivity comes in, but we'll find out. I haven't, to be honest. I've kind of avoided looking at some of that stuff. But yeah, that's not much more I can put there. I guess I could label the pump. That would be a good idea. All right. So now we're going to return back to electronics. So, electrons, not much different. If we rub wax them all together, as I've spoken about multiple times now, if we rub wax and wool together, we pump electrons. It's kind of good because these actually remember the way now. And to be honest, it was like one of those things that it's just interesting, the roots of that. We pump electrons away from their normal levels. Yeah, I almost want to say equilibrium here, but maybe I shouldn't. Well, I said it now anyway. But by giving it a caveat, I suppose, haven't I? Creating a condition where force exists. What if you put this thing here? No, I don't know. Whatever. That's there exists, isn't it? But can you use that with a force? Probably not. I like some of those. I like some of those set theory notations. Where force exists, between the wax and wool. Yeah. Alright, so let's just gonna do that. Before the wax wool, as their electrons seek to re-establish their former positions. Alrighty, so this is a good point. And their balance within respective atoms. And that really is a very important point. And that's something which really I have to focus more on chemistry, that one. So really the conclusion we can make here is that the force attracting electrons back to their original positions around the positive nuclei of their atoms. So they're being attracted. Yeah, the positive nuclei. Interesting. Is analogous to the force gravity exerts. So really, we're talking about gravity. It's almost like the pump doesn't even matter at this stage. Well, I suppose with the pump, we wouldn't have this abnormal state. Well, it's not quite happening there. But anyway, in the reservoir. All right then. So in the reservoir, trying to draw it down to its previous level.